Hi folks, welcome back to Physics with Captain Ron. I'm making this video here to help you out with what is number 9 in the electricity homework here. So there's a picture that looks something like this. First of all, you have to realize what all these values mean. So like this 6, this symbol means micro, and micro means 10 to the minus 6. So this numerical value is 6 times 10 to the minus 6 coulombs. Same thing here. This guy is 1.5 times 10 to the minus 6. This guy is minus 2 times 10 to the minus 6. Coulombs. A couple distances given in the problem, 3 centimeter, 2 centimeter. Now your homework may, based on the picture I'm seeing, I suspect everybody has the same values there for this, so I'll just keep going with it. First question says to find the electric field at a point midway, at a point 1 centimeter to the left of the middle charge. So they're talking about a point about here. Now, the electric field at this point is going to be due to 3 effects. There's an electric field due to this guy, which is going to be to the right. All right, I'm going to call that one E1 here, electric field number 1. Electric fields always point away from positive charges. That value, if I had to calculate it, it's equal to KQ over R squared. This is how electric fields are calculated. The K is the Coulomb constant, 9 times 10 to the 9th, Newton meter squared per Coulomb squared. This is the same value for every single calculation. This does not change. The Q is the 6 times 10 to the minus 6. The R is this distance from here to here, which is 2 centimeters, because it said 1 centimeter along here. Now keep in mind, though, that 2 centimeters is 0.02 meters. So that's 0.02 meters, and it's being squared. Calculate a number for this, and you're going to get a pretty large value, right? Now, there's other stuff going on, right? This charge will produce an electric field here in this direction, and I'm going to call that one electric field number 2. That one also is going to equal KQ over R squared. The hardest part of this problem is going to be getting all these numbers to work out with all these large powers of 10, but this is the same value, 9 times 10 to the 9th. This is going to be this charge, 1.6 times 10 to the minus 6. Divided by this distance squared. So that's going to be that distance in this problem, which is 1 centimeter, which will end up being 0.01 meters. Right? Get a value for this, a number for this. Third effect, this charge will create a field here that points to the right. And the reason that one's to the right, I'm going to call this one like E3. E3 being the field produced by this charge. The field is to the right because electric fields point away from positive charge and towards negative charge. This guy's negatively charged, so the field it would produce here would be to the right. These two have nothing to do with that. When you calculate the third one, KQ over R squared, the same Coulomb constant, 9 times 10 to the 9th. This charge is going to be 2 microcoulombs, or 2 times 10 to the minus 6 coulombs. Common question or common problem people ask is, well, why not minus 2? Because it's minus. That's because the minus sign you use to tell the direction. Once we drew this vector to the right, we have already used the direction, the minus sign for this charge. This is just now a magnitude calculation. Then the distance is total distance from here to here. 2 centimeters and 1 more. So this distance, or this R value, sorry about that poor R there, but is 3 centimeters, or in other words, 0.03 meters. 10 more seconds. When you get done with that, these just need to be added up vectorially. These are to the right, so call them positive. This one's to the left, call it negative. And that should answer that. Use your answer to do part B, keeping in mind that in part B they're talking about a negative charge. So anyway, hopefully that will get you going on that problem. Don't worry, your quiz won't have any problems anywhere near this complex mathematically. All right, everybody have a great day.